Our next problem of this variety here is this problem. We're given 2 points. These are not vectors; these are points in three-dimensional space. P is the point 1, 1, 3, and Q is the point 7, B, 0. And we're also given that the norm of vector PQ is known to be 7. And then what we're asked is what must be the value of B. So what must this value of B assume? And again, we're given an extra piece of information. We're assuming that B is bigger than 0. So we're asked to, once again, we're asked to find B. So these are good. I like to have these kinds of problems because it makes sure that you understand all the pieces. You're able to put together all the little bits. It's not simply compute the number, find the value, get the answer. This is a little bit more involved. You need to sort of keep your wits about you, but it is, I think, straightforward. So what do we have here? We're given the values of points P and Q, the terminal point and the initial point, and we need to find that vector. So the pieces of the puzzle are find vector PQ, then compute its norm, set that to 0. In that computation, this value of B will be involved. From that computation, that should allow us to find the value for B, and somewhere in that mix, we're almost certainly going to need this little piece of information that B is bigger than 0. So let's find all the pieces of our puzzle here. The first is we need to find the vector PQ. And so we find that by taking terminal point minus initial point for all three of those coordinates. So we have 7 minus 1, comma, B minus 1, comma, 0 minus 3. And so what does that give us? That gives us 6, comma, B minus 1, comma, negative 3. So there's our vector PQ. That's piece of the puzzle number 1. What's our next little thing we have? We know that the norm of that vector must be 7. So if we find the norm, set that to 7, that should allow us to find what we're looking for, I think. So we need to find the norm of this. So we know the norm of 6, B minus 1, negative 3 must equal 7, which is to say 6 squared plus B minus 1 squared plus negative 3 squared, and the square root of all that is equal to 7. Well, that gives us some algebra here. I'm going to run out of space here if I'm not too careful, so I'm going to put one more line down here. 6 squared is 36. I'm going to leave this as, well, let's go ahead and square this out. If you do not write b squared minus 1, no, you must FOIL this out. Either square the binomial, use the binomial theorem, go off to the side, FOIL, whatever you do, by hook or by crook, you need to multiply this out correctly. And so b minus 1 squared, if you need to, go off to the side and FOIL that. But by hook or by crook, when you do that, you get b squared minus 2b plus 1. That's this quantity squared is b squared minus 2b plus 1. And then negative 3 squared is 9. It's equal to 7. So, and we need the square root of that to be 7. So what do we have here? We have 36 plus 1 plus 9. So that's 10 plus 36 is 46. Does that look right? So I have 36 plus 1 plus 9. I have b squared minus 2b plus 1 plus 9 plus 36 is plus 46. That's equal to 7. Well, we don't want the square root. We want, we can get rid of that square root on both sides of that equation by squaring both sides of that. Well, if you square the left-hand side, the radical vanishes. So square the left-hand side. That implies b squared minus 2b plus 46 is equal to square the right-hand side, 49. And we almost have a quadratic equation here. We need to get it equal to 0 first. So subtract 49 from both sides of the equation, and then we are on our way home. Because this says b squared minus 2b minus 3 is equal to 0, and that is not particularly challenging to solve. You could use the quadratic formula if you feel like, but that's way too much than you need. A simple factoring will take care of this. And so we have b and b, we have 3 and 1, and we need b minus 3 and b plus 1. And so the zero product property says set those to 0, solve each of those. From that we have b is equal to 3 or b is equal to -1. So which do we put here? That's where we play our final card in our hand. We're also given the fact that we're assuming b is bigger than 0, and so that tells us how to define which of these two we take. Not that one. The value we want is b equal to 3.